Hello everyone, welcome back to another Sudoku episode. Today we're going to be playing Sudoku. So this has got, if there's a thing here, King's Rule and Knight's Rule, and then normal Sudoku. The green thing, the digit in the highlighted cell is the number of nines in an adjacent cell orthogonally or diagonally. Since this is in the middle, it must be 1. And I think this must be 2. Because there could be a 9 here and here. And there would be 2. But I don't think a 1 here would work. Because a 1 here would rule out, or a 9 here would rule out 9s in all of these spaces. And I think the same is true for this 9. Which leaves this space as the only possible 9. Now 8 in this is actually restricted. You wouldn't think it would be, but it is. Let's see. So I think theoretically this should be either 1 or 2. But I can't have a 9 there and there. I can't have a 9 there and there. But 9 is either here or here in this row. But I don't think that there could be 2 9s. Actually, no, this can't be a 9 because then this square is valueless. This can't be a 9 because of anti-knight. So if none of these could be 9s, then this must be the 9. And this must be a 1. So a little bit of nice logic to start it out. Okay, 9 can't be at either of these spots, so we could get it down to over here. Which means this can't be a 9 anymore. So we do end up with this weird pairing. Which is alright. 1s in this box are very restricted, so now 1s can't go in any of these spaces. And now anti-knight here, 1s have to go either there or there. 1s in this square. So 1 can't go anywhere here, because a 1 here would kill all of those, 1 here would kill all those, and 1 here would kill all those. That can't be a 1 because of anti-knight, so 1 here is restricted. A 1 can't go here or here. Anti-knight, Sudoku, 1 is trapped in these spots. So 1 can't go here or here because of those ones, and it can't go there, there, or there. So 1 must be here. And here, and here, and here, and here, and here, and here. Just like that, we get all the 1s. So it's kind of like Miracle Sudoku. In a lot of ways. 2 in this square is very restrictive. So now this can't be a 2, this can't be a 2, and this can't be a 2. So we could get 2 down to these spots. Oh, you know what? In this cell, it can only go there because of the non-consecutive. So now this can't be a 2. And now 2 in this cell can only be here. Look at that. Anti-night plus these 1s lock 2 into these 2 spots. But we already know where the 2 goes there, so that's the 2. 2 can't be in either of these spaces, so it must be in one of these spaces, forcing this into not being a 2. So now if you look at 3s, actually I could try to do 9s, but I see that 3 here is very limited, 3 here. But nonetheless, 8s actually are very restrictive here. Right, this is a 2-8 pair. I mean, 3-8 pair. Four, 5, 6, and 7 go into those other things. Alright, let's look at 3s. This space can't be a 3. The 3 here is restricted. No, I feel like that's too messy. Eight's over here. Eights kills 7, so 7s can only show up in these spots. That doesn't mean much though. Oh, you know what? Where does 8 go in this? area. It can only go there and there. Because it can't go here, 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 or here because of the pencil marks. So 8 can't go here, or here, or down there. So 8 is either wait a sec. An 8 here would kill both of them. Is there no valid 8 to place? No, because there's these options, right? But yeah, neither of these could be 8 anymore. So 8 can't be here. So 8 in this box is restricted to here, which lines up with the 8s down here, right? So now this can't be 8. That 8 reaches by the anti-knight. Put an 8 right there. This 3 gets rid of these 3s. Now 3 is to go somewhere in here, but it can't go here because that would push the 2 there and it would be consecutive. It also can't go here, so that would push the 2 there. So 3 must be here, 2 must be there. Now that's a 2, that's an 8, and that's an 8. That 2 gets rid of this 2, which puts a 2 right there. And a 2 right there. And I think that's all the 2s we can get. Now if you look at 3s, this can't be one. Three can't go next to a 2, so that's a 3. This cell, that's a 3. That's a 3. Now that's a 3. And that's the final 3. What about 8s? Can I finish those up? Yeah, you can't put 8 next to a pencil mark 9. anti-king means that that can't be an 8. Eight next to a 9 will never work. So we can figure out these last couple 9s. I think that's the last 2. So now I could either look at 7s or 4s. I think I'll look at 7s because I see them easier here. There's a plane flying nearby. Very annoying. Get all these 8s in the perfect positions. Is that all the 7s already? Looks like it. So let's look for 4s. Yep, this square has 2 3s seeing into it. So that's the 4. That's all of them. Now we got 6. So let's find a 7 that sees into another cell. Nope. Let's find a 4 that sees into another cell. Yep. Missing number is 6. There we go. So, interesting puzzle. I like the break-in where you see that this has to be a 1. So then this must be a 2, which gives the diagonal. And then you try to science out if this is a 1 or a 2, and it can only be a 1. And then the rest sort of plays out like normal Miracle Sudoku. Although, interestingly, actually, I think it's the same as Miracle Sudoku, because it's non-consecutive plus anti-knight and anti-king, which was the original Miracle. But in any case, neat puzzle. Thanks for watching, everyone, and I'll see you on the next Sudoku video.